this video, I'll be explaining detail about what is kefir. Kefir is a fermented milk drink that is originated from Caucasus Mountain and is made by inoculating milk with kefir grains, which is a combination of lactic acid bacteria, yeast, and polysaccharide. Grains look like a cauliflower for a set, which is not like grains of wheat or rice. During the fermentation process, partially converts the lactose in the milk into lactic acid, giving kefir a slightly sour and tangy flavor. Made from the milk of kefir. Kefir is made from the milk of cows, goat, or sheep, which affects the flavor, aroma, and texture of the final product. Now I will explain details of the kefir. First is the physical appearance of kefir. Kefir looks in a white or yellow color and it tastes acidic or sour. The thick texture and tangy smell is what kefir looks like. Second is the nutritional value. Kefir contains probiotic which helps to improve the digestion system, vitamin B12, calcium, magnesium, vitamin K2, biotin, folate, enzymes, and essential amino acids. The benefit of a kefir is it improves gut health, boosts the immune system, help in lactose digestion, and have anti-inflammatory properties. Using kefir in smoothies, poured over cereal, or used as base for salad, dressing, and dips are also one of the application of kefir. Other than that, kefir also can be drink on its own. Kefir can also be used in baking, and cooking, which is similar to how one might use buttermilk. The fermentation process of kefir. Kefir grains are added to milk and left to ferment at room temperature and at 24 hours. During this time, the kefir grains microorganisms break down the milk's lactose into lactic acid, giving kefir its characteristic tangy taste. The yeast in grains produce a small amount of alcohol and carbon dioxide, making the drink slightly fizzy. Microbes that are used in kefir: lactic acid bacteria, example Lactobacillus kefiri; yeast is Saccharomyces cerevisiae. The fermentation process flow starts from milk inoculation, where milk and kefir grains are inoculated. Second is fermentation, where it takes place at 24 hours and at 20 to 25 degrees Celsius temperature. Then lactic acid fermentation will take place, where lactose is converted into lactic acid. After that, acidification will be started, where the tangy taste of kefir is produced. Then separation and packaging of the product. Final product is the kefir, which is rich in probiotic in tangy taste.
Now I will explain to you the process flow diagram for our kefir production. So basically, our kefir production will be use the supernatant from the fermentation broth. So to start the process, we will store the sweet whey or acidic whey in a tank, and then it will be pumped into the bioreactor for fermentation. Before the fermentation start, kefir granules and salts are added to the bioreactor. Then this mixture is fermented to produce the kefir broth. After that, the fermented broth is then filtered to separate the solid kefir grains from the liquid supernatant. But the solid kefir grain will be used again into the bioreactor to make further fermentation broth. Next, the supernatant undergoes thermal inactivation to kill any unwanted microorganism, ensuring the stability and safety of the product. After that, the thermally inactivated supernatant will be collected in a tank, which indicate in the PFD as TK harvest, and the supernatant is then cooled to -20 degrees Celsius and pass through a clarifier to remove any remaining solids or impurities. After that, it will involve in washing and centrifugation. In the TK washing tank, the clarified supernatant is washed with ethanol and also water to purify it further. The washing is done at 65 degrees Celsius. And the washed supernatant is centrifuged to separate the residual impurities. And lastly, after it have been centrifuged, it will involve in drying, where the residual supernatant is then dried to produce kefir, which is the polysaccharide extracted from kefir grains. That's all from me. Thank you.
The bioreactor used in kefir production is batch bioreactor because it is suitable based on its working principle and control system. The batch reactor can control the temperature and pH in the system. Due to the lactic acid bacteria, lowering the pH of the milk during fermentation is important, so bioreactor allows for pH level monitoring and adjustment. Kefir fermentation begins aerobically and progressively transfer to anaerobic conversion as the yeast uses up oxygen and releases carbon dioxide. Hence, controlling the aeration system is very important. Anaerobic fermentation results in lower biomass production, which allows for more conversion of carbon to the final product and a higher product yield. Batch bioreactors minimize the chance of contamination from outside source by functioning as a closed system. Batch bioreactor is also scalable, flexible for small and large production of kefir.
Okay, now for the improvement under technology, the first one is temperature control, in which the challenge is kefir fermentation is temperature sensitive, and if optimal temperature range is between 20 to 25 degrees Celsius. And the improvement that can be done is implement the precise temperature control using advanced heating or cooling system that can maintain the temperature within 0.1 degrees Celsius. And then a PID controller also can be used for temperature regulation that can help to ensure the consistency. Okay, the second one is mixing and agitation. The challenge is it's inadequate. Mixing can lead to uneven fermentation and hot spot. The improvement that can be used to solve this challenge is use a magnetic stirrer or impeller system for gentle mixing to ensure an even distribution of kefir grain and avoid damage to the microbial community. Okay, next is for the genetic engineering. The first one is metabolic engineering. Its objective is to enhance the metabolic pathway for faster and more efficient fermentation. And its approach is genetically modified lactobacillus, Kefiranofaciens or other key microbes to increase the productions of exopolysaccharide (EPS), which can improve the texture and health benefits of kefir. Second is a stress tolerance. Its objective is to improve the microbial tolerance to acidity and ethanol. This approach is the engineer microbes to overexpress stress response proteins or introduce acid and ethanol tolerance genes to extend the fermentation time and improve the production yield. Okay, now for this slide is about another factor that can affecting the bioreactor and its efficiency. The first one is fermentation time and condition. This challenge is the long fermentation times that has been taken can reduce the production efficiency, and the improvement that can be done is conduct a study to determine the optimal fermentation time that maximize microbial activity and product quality. It's typically around 24 to 48 hours. Second is about the raw material quality, in which the challenge is there are variability in milk quality that can affect the fermentation. The improvement that can be done is to standardize the quality of milk used in order to ensure the consistent fat, protein and lactose levels in milk, and pre-treat milk to remove potential contaminants. And as you can see in the slide, also have the batch bioreactor diagram and also all the each part of the bioreactor.
So I will present for the safety and regulation. In safety regulation, there are CGMP and HACCP. In kefir production, for the CGMP, we have to take a look in personnel, equipment, raw material and quality control. For the personnel, employees must be adequately trained in food safety and hygiene practices in kefir processes. And it should follow strict hygiene practices to prevent contamination in kefir production. For the equipment, it must be regularly cleaned and sanitized to prevent contamination during the production. Equipment also must be calibrated and to ensure accuracy in measurement and processes. And then in raw material, it must be tested for quality and safety before used to produce in kefir production. Lastly, in quality control, it must be regular testing of the finished product for safety, quality and compliance with specification. And it also must be comprehensive documentation of all quality control procedure and result. Next, I will present for the HACCP in kefir production. Kefir is a fermented milk product with a high content of dry skim milk substance that made using a mixture of fermenting microorganisms of thermophilic lactic acid and Bulgarian bacillus, while the total contents of fermenting microorganisms in the finished product at the end of the shelf life is at least 107 CFU per 1 gram of the product. High quality kefir made from goat milk is not easy to buy nowadays. Only a product that contains live lactic acid bacteria, which is bifid bacteria, is useful for health. Their lifespan does not exceed 4 until 5 days. On the shelf of store are mostly found kefir with a 2 or 1 week or even a month's shelf life. HACCP is an integrated food safety control system, the implementation of which is give consumer confidence in the safety of production. That allow them to strictly comply with the requirement of legislation in the field of food safety. And it also demonstrate effective management of food safety in document evidence that can be used in the event of lawsuits. By increasing, there are advantages in HACCP in kefir production, which is it can increase consumer confidence in product, which in turn affect the company's sale and profit. The HACCP system allows the manufacturer to specify document and records confirming that food production is under control. They are increasing the level of consumer and customer confidence in the product itself. That's all for me. Thank you.